Okay, in this lecture video, we're going to talk about content of a sample. And we're going to do that using ratios and percentages. So in this example, let's say we have some copper pennies, which are really zinc with a layer of copper on them. And in this particular penny, we have a 2.554 gram penny. That's its total mass. And let's say out of that 2.554 grams, that there are 2.490 grams of zinc. And we want to know, for this example, what's the percent zinc and what's the percent copper in this particular penny. So we're going to do that by using a percentage. So if we wanted to figure out the amount of zinc we had, we would take 2.490 grams of zinc, that's the part of the sample that's zinc, and divide it by the total, which is 2.554 grams total, and then we would multiply it times 100. That would tell us we had 97.49% of zinc in our penny. Now we could get the percentage of copper by subtracting then from 100 to see what's left, because you can never have more than 100%. And if you did that, you would get 2.510% copper. Or, alternatively, you could have figured out how much copper you had in that particular penny, taking the total mass that you had for the penny, 2.554 grams, and subtracting the component of zinc that you had, and dividing by the total. And either way, multiplying by 100, you would get the same answer, 2.510% copper. So that's an example with a macroscopic object that you're used to. Let's take a look with a molecule. So in this example, we're going to take water. And I can tell you that water is 11.2% hydrogen and 88.8% oxygen. Now, I could be talking about a full glass of water, I could be talking about the percent of hydrogen and oxygen, or I could be talking about one molecule, the percent ratio of hydrogen and oxygen. It doesn't matter, it's the same. So let's take an example. Let's say we have 29 grams of water, and we want to know how much hydrogen do we have present. So the way we would figure that out is we would say 11.2% out of our 100% total times the 29 grams of sample that we had, 29 grams of water. That would tell us that we have 3.25 grams of hydrogen in our water sample. So let's take another example. Let's say we wanted to know instead what mass of water, so how many grams of water do we have to have in order to contain 15 grams of oxygen. So in this example, we would say, well, 15 grams of oxygen has to be equal to some fraction, some percentage of the water. So 88.8% of X grams of water. Because we know that 88.8% of water is oxygen. So 88.8% of what would be equal, so here's our what, 88.8% of what would be equal to 15 grams of oxygen. So in order to do that math, we have to convert our percentage We have to get rid of our percentage sign, essentially. So that equation would look like 15.0 grams equals 88.8% over 100%. That's going to be our ratio, times some amount, right? So this is the fraction of the total is equal to 15 grams. So if you solve that equation for x, you should get x equals 16.9 grams of water is how much water you have to have so that you have 15 grams of oxygen present.